Next type of factoring we're going to be looking at is a sum of cubes. That means you have two things that you can take the square root of added together. So the first 10 perfect cubes are as follows. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so forth. So you know you have this option. You have to have an addition. And you have to have two things you can take the cube root of. That means it times itself 3 times equals, what number times itself 3 times is equal to a cubed? What number times itself 3 times is equal to b cubed? So when you're doing this, I use a couple of things to help me keep track of what's going on. I use the acronym SOAP, which stands for same sign, opposite signs, always positive. Now, the other thing I use to help me create the second parenthesis is I square the first, so a squared is a squared. Then I find their product. And the way I write this is I write it underneath it like a sideways P. And so it kind of looks like a tongue sticking out. And then I square the B. So square, product, square. And that's what creates the second parentheses terms. Let's practice a few times. So, looking at number 11. There is no GCF. So the first thing I look for is, can I take the cube root of each item? So can I take the cube root of x squared, and can I take the cube root of 27? And so that's going to be 3 and x. So I create my first parenthesis, x and a 3. And then I create my second parenthesis and leaving it blank. I'm going to come in with SOAP acronym to help me remember my signs. So same, opposite, always positive. Now I'm going to create the second parenthesis. I square the first, so x squared. I find the product, 3x. I square the last, 9. And that's my answer. So now let's look at number 12. Same idea, but we have this time a 1 in the last spot. Remember, the cube root of 1 is always 1. Any root of 1 is always 1. So I take the cube root of 8w cubed, and that gives me 2w. I take the cube root of 1, and that gives me 1. So I create my first parenthesis, put in the 2w and the 1, and then I give myself space on the second parenthesis so I can go in and fill in my signs. So I go in with the SOAP. So same, opposite, always positive. Then I square the first. So 2w times 2w equals 4w squared. Don't forget we have to multiply that 2 times 2 as well. Then we find the product, which is 2w times 1, so 2w. And then we square the last term, so just 1. Now let's go on to number 13. So we have two variables here. We still look for GCF, and there is no GCF this time. So I'm going to go straight to looking to see, can I take the cube root of each? And how I know that I'm using the cube root method is the powers have to be divisible by 3. And so that's going to give me m, the cube root of 216 n cubed is equal to 6n. So my first parenthesis is m and a 6n. my second parenthesis. I use it to give myself space. So I'm going to go into my parentheses, and I'm going to fill in the signs using SOAP. Same, opposite, always positive. So remember, same was this one. So now, let's fill in the second parenthesis. I square, so m squared. Find the product, 6mn, and then I square. So that gives me 36n squared. And that's my answer. Let's look at 14. So if I look here, it looks like I might be able to take and find something to factor between it, because we always want to when it's that big. But if I look back at my chart, I see that 7 cubed is 343. And 4 cubed is 64. These two numbers don't have anything in common, so I know I can't factor out anything. And so that means I'm going to go straight to that step of seeing if I can take the cube root of both pieces. And so that would be 7p and 4q. So my first parenthesis is 7p, 4q, and I fill in the signs using SOAP. Same, opposite, always positive. So I create my second parenthesis by squaring the first. So that's going to become 49p squared, finding the product. So the product is 28pq, and then squaring the last, 16q squared. And that's our answer. So let's look here. Is there a common factor between these two? And they're both divisible by 4. So I know I have a GCF of 4. And so I factor in what's left. So when I take take 4 and divide it into this, I get 125 a cubed plus 4 divided by 4 is 1. So now I'm going to try to take the cube root of 125 a cubed. Now I'm going to try to take the cube root of 1. So that would be 5a and 1. So my first parenthesis is 5a and a 1. Create my second parenthesis, and then put my GCF out in the front. So now, to do my signs, I look at SOAP. Same, opposite, always positive. So when I fill that in, I do square. So 25a squared. Then I find the product, which is 5a, and then I square the last, 1. And that's the answer to number 15. So let's look at 16. What is the common factor between those two? What can divide into each of those? Well, there is a GCF, so I know I need something. So I have a GCF, and I know that this is made up of 3 and 8, and this is 3 and 125. So 3 is a common factor, and I have a C and a D in both of them. So I have 3CD that is going to be factored out of this binomial. leaving me with 8c cubed plus 125d cubed. So now I'm going to try to take the cube root of both parts of the expression. 8c cubed gives me 2c, and the cube root of 125d cubed is 5d. And so that means that I can go to the next step and actually factor this. So I write down my GCF, 3cd, and then I open up my first parenthesis, and it's going to be a 2c and a 5d. And then I open up my second parenthesis, and then I use the acronym SOAP to fill it in. Same, opposite, always positive. And to fill the second parenthesis, I square it. So that's going to be 4c squared. Then I find the product, which is 10cd, and then I square the last. So 25d squared. And that's the answer to that.